Question 7 is about the Earth's atmosphere. 7.1 states that carbon dioxide is a greenhouse gas, and it's asking us to name another greenhouse gas. And methane, which is produced by rice paddy fields and cattle farming, is probably one of the biggest contributors to the greenhouse effect. So definitely not argon, not nitrogen, not oxygen. The greenhouse gases cause global climate change, give two effects of climate change. We could have rising sea levels, which is caused by melting ice caps. That's another one you can have. You can have more extreme weather, or destruction of habitats. Our next question tells us that 4.1 kilograms of plastic, which is used to make plastic bottles, gives off 6 kilograms of carbon dioxide. So you actually get more carbon dioxide when you do plastic, when you're making plastic bottles. So it then asks us to calculate the footprint of one plastic bottle with a mass of 21.5 grams. So we need to work out exactly how much carbon dioxide you produce per gram. So 6 kilograms divided by, well, that's 4.1, so I'm going to multiply that by 1,000 to give us 4,100 grams. Oops, too many zeros, apologies. So 6 kilograms over 4,100 grams. Gives me a 0.00146 kilograms of carbon dioxide per gram of plastic bottles. One plastic bottle weighs 23.5, so we'll do 0.00146. We'll multiply that by 23.5, and that should give us the number we're looking for. What I did do is I left my exact answer in the calculator, so rather than having to type it in again, rather than having to worry about any rounding errors, all I have to do is multiply that by 23.5, and that gives me a 0.034. 0.034 grams, and I'll need to convert that back into kilograms, so I need to divide that by 1,000 to give me 3.4 times 10 to the minus 5 kilograms of carbon dioxide. Give one way that carbon dioxide emissions can be reduced when plastic bottles are manufactured. You can either use less plastic, so design your bottles so they don't use as much raw materials, or you can use recycled plastic. Either of those will be great. 7.5. Explain how the percentages of nitrogen, oxygen and carbon dioxide in the Earth's atmosphere today have changed from Earth's early atmosphere. So we need to look at nitrogen, oxygen, carbon dioxide. Let's start with nitrogen. And nitrogen has increased, and this is due to nitrogen given out by volcanoes. Also, ammonia has been converted into nitrogen, and finally denitrifying bacteria have released nitrogen in the soil, in the ground, into the atmosphere. So there are lots of nitrogen-based compounds in the soil. Some bacteria are able to take that in, break it down and release the nitrogen back off into the atmosphere. Oxygen next, so we've done nitrogen, that's taken care of. Oxygen has increased as well. Because plants and algae give it out or emit it during photosynthesis. So oxygen has increased because plants and algae give it out during photosynthesis. So oxygen taken care of. The last one, carbon dioxide. So carbon dioxide has decreased. I'm going to bullet point this to save space. This is because plants, algae absorb CO2 during photosynthesis. It's also been absorbed by the oceans. So when the Earth cooled down below 100 degrees Celsius, the water vapour that was in the atmosphere could condense to form the oceans, and CO2 was then absorbed into it. It's also been locked away by the formation of sedimentary rocks such as limestone. It's also been locked away in fossil fuels. So things like coal and oil, they contain lots of carbon. So millions of years ago trees fell down, covered in sediment, did not decay. Over millions of years they turned into coal. You've also got algae that died, sunk to the bottom of the sea, covered in sediment, again did not get broken down because of the lack of oxygen, and over millions of years that formed crude oil.